Hi there, and thanks for using Wyzen's online Ask an Expert feature. My name is Ryan, and today I'll show you how to find a cubic polynomial that takes this form right here, such that this cubic polynomial can be fitted to this data that you see down here. So the goal by the end of this video is to determine the unknown coefficients a, b, c, and d that you see in this cubic polynomial. And notice that we have really 4 pieces of data here. So we have 4 unknowns, 4 pieces of data. So with any luck, we could uniquely determine each one of these coefficients and therefore get a unique polynomial that fits this data. Now, in general, I can think of 2 different ways of solving this problem. The first method is a general method that's always going to work, regardless of the type of polynomial you have and the number of data points that you're given. So we'll talk about that method first. And then I'll show you another method at the end of this video that exploits the fact that these first 3 data points are giving you some information about the roots of this cubic polynomial. And once you have that information, you can actually solve this problem a lot faster. So let's start with the first method, which I call the slow method. The way that you want to think about this first method is you want to start with the data that you're given. And you want to treat this f as if it was the cubic polynomial with the undetermined coefficients in it. So f of x here is going to be treated just like it was on the last slide, as ax cubed plus bx squared plus cx plus d. And what this notation is telling you to do is to plug in -1 in for x into this formula and set that result equal to 0. So that's exactly what I'm doing in this first row here. I'm plugging -1 into my cubic polynomial with undetermined coefficients and setting that result equal to 0. And after a pinch of algebra, you'll see that actually this nasty looking expression simplifies down to a linear equation involving the unknown variables a, b, c, and d. We can repeat this process basically for each one of our data points. So our next one is f of 2 is equal to 0. This is going to require us to plug in x equals 2 into our cubic polynomial and set that result to 0. And eventually that's going to give us this linear equation that you see here. And so we can keep going, essentially building up a linear system that comprises of 4 equations with 4 unknown variables. And so at this point, you have to go off and use a set of techniques called Gaussian elimination to be able to solve that linear system. And I'm going to assume that you're comfortable with that knowledge. So we're going to skip that tedious algebra step and get right to the result of what is the solution of this linear system. And it turns out that if you solve this system correctly, you'll get that a is 2/3, b must be -8/3, c is equal to 2/3, and d is equal to 4. So therefore, our cubic polynomial, if we plug these values of a, b, c, and d back into this form of this cubic polynomial, will necessarily be 2/3 x cubed minus 8/3 x squared plus 2/3 times x plus 4. And so this would be our final answer. So this is the slow method. Basically take your data, plug your data into whatever polynomial you're given, and this will give you a linear system that you have to solve for the unknown coefficients in that polynomial. Now, let me show you the fast way. So for this problem, we're going to exploit the fact that the first 3 data points are actually telling us information about the x-intercepts of my cubic polynomial. In particular, x equals -1, x equals 2, and x equals 3 must be roots of this cubic polynomial. Now that means that the cubic polynomial needs to factor into 3 linear factors of x plus 1 times x minus 2 times x minus 3. If you don't believe me, try setting this polynomial equal to 0, and you'll recover these roots that you see over here, -1, 2, and 3. So basically at this point, we've almost determined our cubic polynomial up to this unknown constant a that could be multiplying these 3 linear factors. And so how do we determine what that capital A value is? Well, this is where the 4th and final data point comes into the rescue. So what we're going to do is use this 4th data point, plug in x equals 0 into our factorized polynomial, and set that product of linear factors times this unknown constant to 4. And so that's going to give us an equation that looks like what you see right here. A times this sequence of numbers where I've plugged in 0 for x is equal to 4. And if you just simplify that equation just a little bit, you can solve for this capital A variable and find that capital A is equal to 2/3. So in conclusion, Our cubic polynomial must take the form 2/3 times x plus 1 times x minus 2 times x minus 3, or if you expand this all out using some tedious algebra, you will recover the same polynomial that we found using the first method. But keep in mind, this second method only worked because we were given roots of this cubic polynomial, and that allowed us to speed up the computation. If you're not given information about the roots of the polynomial, then you're back to using this first method where you have to use the data to write everything in terms of a linear system for these unknown coefficients and solve that linear system. Now with that, you've given two methods now on how to solve this problem. If you have any questions, feel free to reach out. I'd be happy to explain more in detail. Thanks so much and have a great rest of your day.